Hello and welcome to another episode of Mr. Johnson's Math Class. In this two-part episode, we are going to look at squares and cubes. And in part one, you are going to learn how to take the square root of perfect square. When you hear the word square, you probably envision the shape of a square. Perhaps you think of places that you have seen squares. You may even think of how a square math class is. Nah, I'm just teasing. Who would think that? But squares are all around us. They're in design, they can be used to create patterns. You may even be asking, what do squares have to do with numbers and math class? Well, I'm glad you asked. Some numbers are called square numbers. Perfect squares have some interesting qualities. By the end of today's lesson, you need to be able to answer the question, if you were told the area of a window, how can you determine the side length? So if I told you that the area of this window equals 144 square inches, how could you tell me the measure of one side? So how long is just that side? First, let's talk about what is a square root. What does it look like? And how do we find the square root? So in the expression, the square root of 64, this symbol here, the little crazy looking division sign, is called the radical sign. And 64, so the number under the radical sign, is called the radicand. So if we wanted to find the square root of 64, so if I need to take the square root of 64, so if I need to take the square root of 64, if it's written like this, we're only looking for the positive roots of 64. So we're looking for what number times itself equals 64. This is the same thing as the square root of 8 times 8. So there we have two of the same thing because the square root is really just a number times itself. So the square root of 64 could be written as 8 times 8 or just 8. And if you weren't sure of doing it this way, we could always take out the factors of 64. So if we were figuring out what times what goes into 64, maybe you didn't start with 8. Maybe you started with 2 times 32. Well, you look at these, and these are not prime factors, so we can keep going with the prime factorization. And what goes into 32? Well, maybe I just went with 2 again. So 2 goes into 32 16 times. These are still not prime factors, so I could keep going, and let's just keep going with 2, and we're seeing a whole bunch of 2's appear, so this is really 2 times 8, and I'm going to keep going, as you probably guessed. This is 2 times 4, and this is 2 times 2. We see a whole bunch of 2's here, so if we multiplied all this back together, 2 times 2 times 2 times 2 times 2 times 2, it's going to equal 64. But if we need the square root of 64, we need to know what times itself makes 64. Well, I see a whole bunch of 2's, but I'm looking for what times itself. Well, 2 times itself twice isn't 64. So if we were to put all this back together, we could see that 2 times 2 times 2 times 2 times 2 is 64, and you have 2 times 2 times 2, which is 8, and then 2 times 2 times 2, which is 8. So therefore, 8 times 8 is 64. That same process we could use to find the square root of 49. You may automatically look at this and recognize that 7 times 7 is 49. So therefore, the square root of 49 is 7. And once again, if it's written like this, we're only looking for the positive. Or we could go back to our factor tree and we look to see what goes into 49. Well, besides 1 and 49, we're pretty lucky with this one. It's 7 and 7, so therefore we found our pair. We found what times itself makes 49, so the square root of 49 is 7. So some more examples here. We see one that looks a little different. It's got this plus minus sign out front. So if I need the positive, if you see this plus minus sign, this is telling you that you're looking for both the positive and the negative roots for the square root of 81. Well, the square root of 81 is 9 times 9, which is really just 9, because the square root of 81, the square root, we're looking for what times itself. So 9, but because we've got this plus minus sign out here, we have to include the positive and negative roots for the square root of 81. Now, if we wanted to look over here at the square root of 400, it might help us to look at this number 4 first, and we know that the square root of 4 is 2. And knowing that's actually going to help us with a little shortcut here, because this is kind of a big number. So if we only wanted the square root of 4, we know we could take 2. But we're not looking for just the square root of 4. We're looking for the square root of 400. So the square root of 400. So what times itself makes 400? Well, I know that 20 times 20, because 2 times 2 is 4, and I've got to get to the hundreds, so 20 times 20 is going to give me 400. So the square root of 400 is 20. When it's written like this, we're only concerned with the positive roots, so I only include positive 20. Now this negative outside means I'm looking for the negative root of 0.16, or 1600ths. If this negative were inside, we would have a little bit different animal, but it's on the outside, so that's what we're concerned with. So this is the negative square root of 1600ths. Now, you may intuitively know that the square root of 16, so if we only wanted the square root of 16, well, you may know that 4 times 4 is 16. So really, if we wanted the square root of 16, we know that's 4. But I'm not looking for the square root of 16. I'm looking for the negative square root of 0.16. But if we understand that 4 times 4 is 16, that gives us a nice little shortcut and a reference point. So the negative square root means I'm concerned with the negative roots of 1600ths. Well, this is the negative square root of 4/10 times 4/10. So the negative square root of 0.16, or 1600ths, is negative 4/10. And finally, we have a fraction. So if we wanted to find the square root of 16 over the square root of 25, we would treat this just like we did all the others. And this is really the square root of 16 over square root of 25. Well, the square root of 16 is 4. Square root of 25 is 5. So the square root of 16/25 is 4/5. So back to our essential question, which was, if I gave you a square, or I gave you a square window, I gave you a rug, something of that sort, and I told you the area, could you tell me the length of one side? So if I told you that this rug has an area of 121 square inches. So essentially what we're saying is all of the space inside the rug is 121 square inches. But I need to find the length of one side. So maybe I need to know if this rug is going to fit in the space that I've got reserved for it. and I need to know what size rug to purchase. And if I know the square inches, so I know the space on the inside, how can I find the length of one side? So I need the length of this side. Well, I know that to find the area of a square, we do length times width. But since I know that on a square all sides are the same, the area of a square is really, and anytime you're multiplying something by itself, essentially all you're doing is squaring it. So side times side is really side squared. So if the area equals side squared, and it tells me that the area is 121 square inches, well, I'm going to substitute 121 for area, but I need to find the side squared. Well, if you'll think back to what we know about equations, solving all equations, you are undoing or using inverse operations. And the inverse of squaring a number is square root. So the inverse of square number is taking the square root. Well, if I need to find just one side, well, I have side squared. So if I undo that by squaring, or if I undo the square by square root, then we can find that the side is equal to the square root of 121, and the square root of 121 is 11. So therefore, one side measure is 11 inches. So this side is 11 inches long. So if you are given the area of a square, you can now find the length of one side using what you know about square roots. Stay tuned for part 2.